For our first lesson in 10.5, we'll be determining the signs of cosine theta and sine theta. So when theta is not a multiple of 90 degrees, so 90 degrees, 180 degrees, 270 degrees, and 360 degrees, it is in one of the four quadrants. And let's remember that in the coordinate pair cosine theta and sine theta, they stand for your x and your y. Now if you can't remember which one is the x and which one is the y, just think of the alphabet. So cosine comes before sine in the alphabet, as x comes before y in the alphabet. So cosine theta is your x value, and sine theta is your y value. Now let's take a look at our quadrants. In quadrant 1, theta is between 0 and 90 degrees. In quadrant 2, theta is between 90 and 180 degrees. In quadrant 3, it is between 180 degrees and 270 degrees. And in quadrant 4, theta is between 270 degrees and 360 degrees. Now if you can't remember if it's positive, or negative, or so on in your coordinate pair, just sing this to yourself. 2 positives in the first quadrant, negative, positive in the second quadrant, 2 negatives in the third quadrant, and positive and negative in the fourth quadrant. And that's all there is to determining the signs of cosine theta and sine theta. For our second lesson in 10.5, we will be determining sine theta from cosine theta and vice versa. So first, we have the Pythagorean identity theorem, which states that for all theta, cosine theta squared plus sine theta squared equals 1. And so once we know one of these values, we can find the other. So for our example problem, this is what we're told. Theta is between negative 3 pi over 2 and negative pi. And that sine theta is equal to 1/2. So now we have to find cosine theta. So first we have to restate our problem, which is cosine theta squared plus sine theta squared is equal to 1. We can also write this as cosine squared theta plus sine squared theta is equal to 1. And we know the value for sine theta is 1/2, so we'd substitute that in. And we know that 1/2 squared is 1/4, so now we have cosine squared theta plus 1/4 is equal to 1. And then we'd subtract 1/4 from each side to get 3/4. And to get cosine theta by itself, we'd have to take the square root of each side. So now we have cosine theta is equal to the positive or negative value of square root of 3/4, or the positive or negative value of the square root of 3 over 2. As we know, 4 is a perfect square, so it would be 2. Now we can even go further by using this information to determine if we should write positive or negative. So we know that negative 3 pi over 2 is right here, and that negative pi is right here, meaning that our value should be right around here. And since we're trying to find cosine theta, which is our x value, and it is in quadrant 2, we know that should be negative. So our answer would be negative square root of 3 over 2. But if we weren't given this information, we would just keep it as positive or negative square root of 3 over 2. And that is how you use the Pythagorean identity theorem. For our third lesson in 10.5, we will be using symmetry to find sines and cosines. Once you know the coordinates of one point on the circle, you'll be able to find many other points. For second quadrant values, when theta is between 90 degrees and 180 degrees, the rotation of theta, 1, 0, is in the second quadrant. Every point on the unit circle in this quadrant is the image of a point on the circle in the first quadrant under reflection over the y-axis. For example, the point cosine 150 degrees, sine 150 degrees is the reflection image over the y-axis of the point cosine 30, sine 30, which is a point in the first quadrant. Remember that under reflection y, the image xy is negative xy. So the first coordinates of the points are opposite, but the second points are equal. So with these 2 points, we can say that cosine 150 degrees is equal to negative cosine 30 degrees. When you put these two values in the calculator, you will get negative square root of 3 over 2. And since the y values, sine 150 degrees and sine 30 degrees, are equal, you will get a value of 1/2. For third quadrant values, a point in quadrant 1, when you rotate it 180 degrees, gives you a point in quadrant 3. So to find sine theta or cosine theta, when theta is between 180 degrees and 207 degrees, which is the third quadrant, think of the angle with measure theta minus 180. For example, the point cosine 210 degrees sine 210 degrees is the image of cosine 30 sine 30 under a rotation of 180. So since the image of xy is under a rotation of 180, is negative x, negative y, this point has coordinates negative cosine 30 degrees, negative sine 30 degrees. So sine 210 degrees should be equal to negative sine 30 degrees, which they are, as if you put them in your calculator, you will get the value of negative 1/2. And that's all there is to 10.5.